So today we are going to do two past papers because we finished the syllabus last time because we were waiting for the slides to be published. Okay, right. So first we are going to do 2020. 2020 paper, MCQ and the second paper. Okay, so that is what we are going to do first. Then we will be doing the 2019 paper as well, and you will see that pretty much the two papers are the same. And remember, both the papers are all syllabus. So you are the new syllabus, okay? But you should be able to answer more than 90% of the questions without any issue. Without any issue, okay? Right. So let's take the 2020 paper MCQ, okay? So you get two papers, the MCQs, you get about 25 questions. Right, so let's take one by one. So you can see that the question number 1 to 5 are related to subnetting, right? Subnetting. So let's quickly do, because we did the subnetting in very great detail at very beginning, right? Very beginning. I did subnetting about two months back, okay? Right. The machine, now what is the idea behind subnetting? We can create our network into subnetworks, but the external router may see it as one network. Okay, so likewise, we can further subdivide this into 2 or 3, and this router will see all these as one network, and that is how we can make smaller and smaller and smaller and smaller network subnetworks. But the intermediate routers will have less number of entries because, for example, although there are 3 subnets, the router somewhere here will look at it as one network or one network. So that is the idea behind subnetting. Okay, right. And also we have the classes: class A, class B, class C, with default subnet mask or the default mask. Then we can further borrow bits from the host side to create subnets. So it is driven by two things: how many subnetworks we need and how many machines we need for a particular subnet, or maybe combination of both we have to decide. Okay, right. So in the MCQs, they don't go into great details. They are just asking very simple questions only. Okay, they just check whether actually these kind of questions are available in A-level ICT paper. Actually, if I give these 5 questions to A-level ICT student who is preparing for the exam seriously, he or she will be able to answer these questions. Okay, so therefore don't think that these are difficult questions. Okay, even A-level ICT we have these. Right. The machine in a network is configured with IP address 192.248.16.10, and the broadcast address is 192.248.16.31. So the question is, what is the subnet mask of this network? I think we did this kind of a question in the past also. So here what you have to understand or figure it out is which portion is not changed. Now clearly you can see that up to this point, it is not changed. So that means whatever that playing is happening in the 4th octal. So therefore, first thing you have to do is convert this into binary, convert this into binary. So that is the starting point. Okay, right. So let's convert 10 into binary. 5 0 2 1 1 0. That is 1 0 1 0. That means 0 0 0 0 1 0 1 0. If I make a mistake, just let me know. Okay, 1 2 4 8 10. Right. Okay. So the rest of the stuff I am not interested. Now 31. 15 remain the 1, 7 remain the 1, 3 remain the 1, 1 remain the 1. That is 5 ones. Okay, 1 1 1 1 1. That means there are 3 more zeros. Okay, 3 more zeros. So that is, now this is the broadcast address, Remember, broadcast address is making all the bits beyond the subnet portion to the 1. Okay, so we can see that yes, they are all ones. Right? It has to be, right? So you can see that they are all ones. Right? And how many ones are there? 1, 2, 3, 4, 5. So that means this should be the host part, and this must be the subnet part. We don't care where the exact thing is, but most probably this will be a class C address. Okay, then it will be somewhere here, but we don't need that for the answer. Okay, and therefore this is 1, 2, 3, 4, 5. You can see all are ones. So then here also 1, 2, 3, 4, 5. Right, and this is the broadcast ID, and this is one of the machine. Okay, right. So the question is, what is the subnet mask? So the subnet mask must be in CIDR notation. It has to be 888. That is 24, and another 3 27. Actually, that is what they ask in the second part. Okay, CIDR notation. It has to be /27 because 888 24 25 26 27. Okay, so that is easier one. Already we found. Right, so subnet mask is the same thing. You write it in something like IP address. So that means this is 255 because your subnet mask is up to this point all are ones, afterwards all are 0. So all ones in all 7 bit is 255. So therefore 255, 255, 255. So then 3 ones and 4 zeros, right? 3 ones and 4 zeros is, sorry, 3 ones and 5 zeros. You have to calculate 1, 2, 4, 8, 16, 32, 68, 4, and 128. 32, 64, 128. That is 10 plus 4, 14. 1 goes, then 10, 12, 1, 2, 2, 4. So that is 255, 255, 255, 224. So answer is D. Now we got two answers. First one answer is D, second one answer is B. Okay, so let's see the answer. D and B. Any questions on that? Because you have only 1 week for the exams, so don't go with doubts. Of course, this subject you have to go with some sort of a doubts because you know that network is, there are degrees, right? A degree dedicated for networking. Cyber security is computer networking, right? So you are learning it in 1 semester. So obviously you cannot go to the exams without any doubt on the network subject, right? But concepts like subnetting, you must be 100% confident, or you have to ask questions and clarify. Okay, especially the idea behind subnetting as a whole. So don't just memorize. Okay, right. Third one. What is the network address of this network? Because these questions are related. Of course, the subnet broadcast ID is when all the bits are 1. The subnet ID is when all the bits are 0. So therefore, anyway, you can't change this. Anyway, they are 0. So you make all the others 0. So then obviously, anyway, we know that these things are not going to be changed. So therefore, 192.124.16 and all 0 means 0. So therefore, the subnet ID is going to be 192.248.16 0. 192.248.16 0. So that is B. Third one answer must be B. Fourth one is again very easy question, right? How many IP addresses can be allocated to machines? Now it's very important. How it's not how many IP addresses. Remember, we have to reserve 2 IP addresses, the subnet ID and the broadcast ID. So what the question is, how many IP addresses can be allocated to machines? So that means -2 value. Okay. So anyway, already we know the 2 now IP addresses we have to reserve. So that is one of these, this one, the broadcast ID, other one is the 192.248.16 0, right? So anyway, we have how many bits to play around? 5. So when we have 5 bits to play, there are 2 to the power 5 patterns. 2 to the power 5 means 2, 4, 8, 16, 32. That means we are getting 32 IP addresses for host machine for our subnetwork, but we have to reserve 2 IP addresses. One is this and the other one is subnet ID. So therefore, we can have 30 IP addresses that can be assigned to the machines or the host. So the answer must be E. Right. Fifth one. So that is interesting question. Assume that the subnet mask of this network is denoted by /s, and we know that it is already /27. Okay, but the question is based on that the X. Okay, assume that the subnet mask of this network is denoted by /s in CIDR notation. This subnetwork is to be divided into 2 subnetworks. That subnetwork is going to be divided into further 2 subnetworks. Okay, of equal size. Now, those are very important. Equal size. That means just we are going to break it into 2 subnetworks of the equal size. The subnetwork thus created have the subnet mask /y. Right. So that is the subnetwork of that subnetwork is going to get subnet mask of /y. It's actually subnet mask in the CIDR notation. Okay. Which of the following describes the relationship between X and Y? So it's very easy. Now already this one assume it's /x, right? So if you are going to break it into 2, that means we are going to borrow how many bits? Just 1 bit, because 1 bit we can have 2 bit patterns, 0 and 1. So therefore we can further subnet it. We are getting 2 subnetwork, one with 0, one with 1, and all the other bits are available for the host machine. So therefore, our next subnet, the next level subnet is going to have X plus 1 bits, because if it is, for example, in this case, 27, when we break it into 2 subnetworks, those subnetworks are going to have /28 because we are borrowing 1 bit further for another subnet. Okay. So therefore, the answer is your Y must be X plus 1. If they say we are going to create equal size 4 subnetworks, then we need 2 bits, right? 0, 0, 0, 1, 1, 0, 1, 1. So in that case, Y equal X plus 2. If they say we are going to create 8 equal size subnetworks, that is 2 to the power 3, then it is Y equal X plus 3. Right? I hope you get it. Okay. And answer is B. Answer is B. Okay. Right. 6. Which of the following is not a field in the UDP header? We discussed the UDP headers in the revision we did, I think last Wednesday, right? Yes. So remember, UDP is something to do with, in the OSI architecture, we have the physical layer, the logical or the link layer, network layer, transport layer, the session layer, presentation layer, and the application layer, right? Application layer. And here we have the MAC address. Sorry, here we don't have any addresses. Here just the physical connections, bits, and other things. Logical link layer, we have the MAC address. Okay, MAC address and the data frames, concept called data frames, and of course the switches, layer 2 switches. In the network layer, we have the IP address, okay, an IP protocol, and also the IP packets, the routing and the router. And in the transport layer, right, we have the concept called port, right, port or the port address, and also the 2 protocols, UDP or TCP, and this is where we connect end-to-end connection, reliability. So I explained that last Wednesday. Okay, so this is all about the reliability. How can we establish a connection between 2? This is end-to-end. This is hop to hop. But transport layer is end to end, right? Remember we discussed the upper layers will not see the complexity of these layers, but it is presented by this layer as a more reliable service. So this make unreliable network act like reliable thing. So if data packets are lost, the transport layer makes sure that those data packets losses are again recovered and stuff, things like that. Okay, right. So therefore, the concept called port address ECF. What is a port number? So originally, port number is used to denote your running program, which is related to network. Right. So HTTP, the well-known port number is 80, something like that. Okay. And of course, the client also can assign a port number. So which we can use for, because the concept called port number is more important for the servers, the web server, right? File server, email servers, etc. But the concept is there in the client side also. So therefore, we can use this client side port number for some other things like port address translation when we are running out of IP addresses. Okay. But anyway, we must know that the port number is something to do with the transport layer. Okay. Now let's see the answers. So remember, the port number is very critical part of the UDP header, right? So therefore, source port is there. Okay. It must be in the UDP header. Destination port must be in the, because the IP, source IP and destination IP is in the IP header. So the source port number and the destination port number is in the UDP header. Destination IP is something to do with the IP header, right? So then the UDP length, UDP checksums, remember, even the UDP do certain level of error handling, right? UDP length and those things are also there, right? So that you have to remember that header diagram, okay? So therefore, what is not in the UDP header is the IP addresses. IP addresses are in the IP headers, okay? IP headers. So therefore, what is not in the UDP header must be C. Okay, let's see whether it's C. Yes, C. Okay, so let's open your note and check whether it's mentioned in your new syllabus one, because this is all syllabus answer anyway. A question paper, a transport layer. So we just discussed this last Friday, last Wednesday. Yes, a UDP header format. You can see source port, destination port, UDP length, UDP checksum. So your syllabus also is the same, right? It's the same. It's because that is concept, right? Concept will not change. Right. So the answer is therefore destination IP address. So the network subject, you have to tackle it in a, you can't just memorize and go and pass network subject. Okay. So network subject is someone who solidly understand the concept. Right. 7. There's a TCP connection with the source IP address of IPM. Now, when this kind of a question is given, you have to spend a bit of time because you get 1 hour. So now you can see only 25 questions. I am already in the 7th question. Right? You get 1 hour. So usually you will not running out of time for network subject. Okay. So therefore, read this, and also while you are reading, transfer it to a diagram. That is a must for this kind of questions, because it's all about that computer, this computer, that router, this router. So many things will be mentioned. So unless you put it into a diagram, you will be really confused. Okay. And also pay attention to these words, right? Cannot be correct, right? Right. So let's read it. There is a TCP connection with the source IP address IPM and port number PM to a server S. So that means one particular machine is connecting a connection to a server. So this is the server, they call it S, and this is just a machine. Okay, there's a connection. with the server. And now let's put it. There is a TCP connection with the source IP address. So this is the source. This is the destination. Source IP address, they call it IPM. And port number PM. Remember, the source has IP address and port. Destination has IP address and port. Okay, IP address is network layer concept. Port is a transport layer concept. IP address is exposed to the hops, routers, but port number is not exposed to the routers because a port is a transport layer, end-to-end protocol, right? Consider a simultaneous TCP connection to server Y. There's another server that means. So this is server S. So that means there's another server Y. Another server Y. Server Y, S is not equal to Y. That means there are two different servers. With the source IP address IPX, now there's another connection, right? So they are not talking about a different client. So therefore, obviously it has to be the same client. But there it says the source IP address IPX and the port number PX. Now you may be wondering, how can of course the same client can have different port numbers, because maybe this is your email client, the other one is your browser. Maybe one is browser, other one is your FTP client, or maybe two browsers, your Firefox and Edge. So therefore, obviously they can have different port numbers. Then someone will ask, how can the same computer has two different IP addresses? Of course, very rarely it can have, okay. For example, it may be using two different network ports, like, okay, so, or else maybe it's not actually, it has that, it is the address translation has given it a different IP address, right? So those are rare, but very rarely same computer can communicate with different servers as different IP addresses, okay, for security and other configuration reasons, okay, right? Right. So the question is, but it's very rare situation. Remember, it's very, very rare situation to have two IP addresses. Okay. Right. So the question is, what is the thing that cannot happen? Right? What is the thing that cannot happen? Now remember, if it is IP address, two different IP addresses, it is something to do with that intermediary guy, like proxy server or something, because it can take out the IP address and put it into a different IP address. Okay. Right. Now let's see. IPX equal IPM. So that is X and name, and port X equal port temp. Now, if it is two different communication session, definitely port must be different. So that is something you have to understand, okay? Because it's two different connections, right? Two different connections means it has to be two different ports. So therefore, definitely PM and PX must be different. And this says PX equal PM, right? PX equal PM. No, right? How can the PX, if PX is equal to PM, the data packet that is coming from S, right, and coming from Y will come and give you the data packet, right? So then your computer, operating system or whatever, that agent, right, working on behalf of the net transport layer will be confused whether to give it to this program or to that program. So therefore, those two programs must be having two different port numbers. Okay, so but this says the two port numbers are the same. So port numbers has to be different. So this one says the IP addresses are the same. This port is number is smaller number than that port. Of course, it has to be different. Okay, it has to be different. We don't care whether this, because port numbers, there are well-known port numbers as well as there are some arbitrary port numbers also. Okay, So therefore, your computer will decide what is the port number that we are going to use. If it is a client, but if it is a server, there are well-known port numbers, like usually 80 for the web, 443 for HTTPS, blah, blah, blah. Okay. Right. I ask you to remember the port number of POP, IMAP, SMTP, FTP, POP, right? At least those five. At least those five. Okay. Right. But in client side, it is more flexible because these are not well-known port numbers. Usually, you always will give a sort of a random port number. But port number has to be changed. Otherwise, how can it now? Because when a data packet is sent to S, it has to put up the port number and send. So then we are getting the response, the same port number. Now here the source port number, this will be the destination port number. So therefore now OS knows that it has to be given to this. So that is the idea behind port number. That is why port number has to go round trip. That is why we can do port address translation. So we need something that goes on a round trip. If you want to do the port, some gimmick with IP addresses or the changing your presentation, okay? You represent to someone else using a different identity. So this port number goes and comes. Then it can be given to the relevant program. So therefore, port number has to be changed. So it doesn't matter. Port number has to be changed. Port number has to be changed. Port number has to be changed. Okay. But here it says port number is same. And here also it says port number is same. Okay. So port number cannot be the same. Okay. Port number cannot be the same. But this one says IP number is different. Right. IP number is different. So I told you that IP number can be different in a rare situations, right? Rare, what they ask is cannot be correct. Okay, cannot be correct. So here port numbers are the same, so that cannot happen. Here port numbers are the same, and in case port numbers are the same, at least your IP number has to be different, right? So then there's again uniqueness. Right? There's a uniqueness. So that means you are representing your connection through a different connectivity or your interface or whatever. Okay. So that is, if the port number is same, at least the IP address has to be changed. So that has to be configured by other networking software. Okay. So therefore, though this looks like again cannot happen, since IP address is different, so there's a remote possibility. Very rarely that happens, but that still it can be identified unique because the connection is represented by combination of IP address and port number. Anyway, in the enterprise application development, the next subject, one of the topic that I have to cover is socket programming. So there also we will discuss socket is represented by combination of IP address and port number. So therefore, what we need is a combination of IP address and port number must be different. So therefore, this is also okay, though the port numbers are the same, IP address are different. So therefore, so these are okay because port number is different. Okay, port number is different, but this one is also okay. When the port number is same, at least the IP address is different. But if both IP address and port numbers are the same, now there's ambiguity. There's ambiguity. Okay. Right. So therefore, answer must be the cannot be correct. Answer must be A. Okay. 7. Answer must be A. 8. An application writes the contents of a file into TCP connection starting from the first byte in the file in the order of the byte appearing in the file. So actually, I have no idea about this question. Okay. Anyway, we'll read the question. I will just skip this question for the time being. Okay. Because this is the first time we are doing this paper. Because I also got this, opened this question actually today. So then I found that this question is a little bit confusing, but if I found a way, I will let you know. Okay, I will let you know. But anyway, let's read the question. An application writes the content of file into a TCP connection starting from the first byte in the file. Say your file has set of bytes. So it says you are writing the first byte, byte number 1. Right? In the file, in the order of the byte appearing in the file. Which of the following statement can be true? Select the most appropriate answer. That means it has to reach to the other side. So the first byte will be sent, then the second byte, third byte, etc. Okay. Right. So now the first byte, it has been sent. Okay. Again, read. An application writes the content of a file into a TCP connection, starting from the first byte in the file in order of the bytes appeared in the file. It only says that the first byte has sent. Which of the following statement can be true? Select the most appropriate answer. So the answers are: the receiver is guaranteed to receive the full content of the file. The receiver has received the first, second, and third bytes in the file. The receiver has received the first 6 bits of the file. The receiver has received the 8 byte, but not the 7th byte. In the file size, if the file size less than the TCP segment size, all the content in the is guaranteed to be delivered in one segment. So unfortunately, this question only says that the first byte has left. Right. Again, let's read it. An application writes the content of file into TCP connection starting from the first byte in the file in order to of the byte. It says application write the content. I don't know, maybe that byte has successfully reached. I don't know, is that what they mean, or is it just it has left? If they just say it has left, I think this question has no meaning for me. But at least if they say it has reached the destination, it has some sort of a meaning, right? Some sort of meaning. That means basically this source knows that, or the source has received the acknowledgement saying that the first byte has been reached. Okay. Now remember, we discussed something called that window. Let's see whether we can use that concept to see whether we can come up with some sort of answer. The concept called that sliding window. It was again in topic 5, right? Yeah, topic 5. Right. So it looks like this question is related to something like this, but not really this one. Something to do with the sliding window. It looks like. Right. So this is how the handshake occur, but this is not directly related to handshaking. Right. So you can see that it sends the first. This is just example. So the first byte is sent and you get the acknowledgement, then only you send the second byte. And sorry, this is they are saying the buffer we are having 4 kilobytes, right? Because initially sender doesn't know the buffer size. But now when the first 2 kilobyte is sent, the acknowledgement says, okay, we have 2048 remaining, because altogether they have 4 bytes. 4 byte means 1000, 5000 odd, right? 1024 into 4. But now they have received 2 kilobyte. Therefore, they are saying we have 2048 remaining. Okay. Now it is sending another 2 kilobyte. Now it is saying that, okay, now it is our buffer is full. Our buffer is full. Okay. So then it has to wait. So that is what is meant by sliding window. Right now the sender is not going to send anymore, because the receiver has acknowledged the receipt, but the sender has informed you that my buffer is full. Now assume that the 2 kilobyte is read. Now again it is acknowledging, saying that now again 2048 of my buffer is free. Now it can send another, right, 1 kilobyte to even 2 kilobyte. And again, it will say, either it will say it's full, or it will say now, yes, I have consumed something, and now this is something, this much is available, and that is how it happens. Okay. But this question is just saying that we have sent 1 byte and nothing else. So I don't know how to derive an answer with just that information, because they have not mentioned anything else. Okay, so just think about it, and if you feel like you got an answer, just let me know. Okay, just let me know. I will also just double check if I have more time. Okay, because I'm also somewhat busy, because all of you guys are having exams, not only just right, 3, 5, 7. Okay, are also happening now. Anyway, uh, so let's double check the answer, because I'm not very sure about the answer. Actually, I just double check the answer and I can't even justify what is how it is happening. Okay, so the eighth one, the answer they have given is B. B means the receiver has received the first, second, and third bytes in the file. Okay, so that is the answer given. How can you say like that? Okay, so that, think about it using the note, and if you get a logic, just let me know. Anyway, I will also have a look at it. Maybe right. If I got a possible at least justification, I will let you know. Okay, right. 9. Which of the following is a field in the TCP segment header? Now again, TCP, this is TCP header, not the IP header. TCP header, remember we have the two ports numbers, the checksums, the lengths, and those things, right? මතක නේද? දැනුත් අපිට පහළට ගියේ UDP header එකේ TCP header එකේ පොඩ්ඩයි වෙනස් තියෙනවා. TCP header has more fields than the UDP header, because there are some flags, more flags. Right. So this is TCP segment header or the TCP header. Source port, destination port, right? And sequence number, acknowledgement number. So sequence number is the current data packets sequence number. Acknowledgement number is the, when you are receiving, you get the acknowledgement number. Some checksums, and of course this is the data for the payload. Window size, urgent pointer, right? Where if you have some urgent data, where do you have to find the urgent data, which from which byte? The window size. Okay, and there are few and TCP header length, and there are some flags like finish. You have to say that this is used for synchronization, handshaking. There's another one for resetting the connection, disconnecting, or the finishing. So likewise, we discuss those things, and this is when you're acknowledging, right? This is for the urgent data, right? So we discuss those things. Okay, right. So which one is relevant to our answer then? Source IP address is not part of the TCP header. That is something to do with the IP header, because IP address is something to do with the IP. Source port, yes. Destination IP, no. What is this? I think ether type, no. MAC addresses, no. MAC address is not something to do with the TCP. It's in the logical link layer, right? This is passing even the network layer. This is the transport layer, right? So MAC addresses are something to do with the logic or the link layer. So the correct one they're asking, the source port, destination port, checksums, and other things, sequence numbers, flags, etc. Answer is B. 10. Which of the following is the protocol used in trace route utility? Right. So this was not, I think this was not mentioned in your note, but I think this was mentioned in the old note, right? So therefore, I just went through your new note. It's always better. I may share you the old BLE notes as well, all syllabus BLE notes. Okay, I will definitely do that. Just go through the, now you should be able to read and somewhat understand the whole set of notes, because subject is not different, right? Networking is networking. Don't think you can't think that the way we network in 2 or 3 years and the way we do networking today is different. And just your syllabus has changed. So therefore, now you are in a very good position to understand at least about 90% of the all VLE node. Only thing is the syllabus is slight change. Okay, I think they all syllabus note. I think this was mentioned. I don't know whether your one has mentioned this. The trace route utility. Remember, the ping utility. What is the protocol use? Trace you, because I think this question they had asked in 2019 second paper. Right? What is the protocol used for ping and the trace route? And you know the difference between ping and trace route, right? So ping is just to check whether we can access the server. That's it, nothing else, right? For example, I explain this. So if I just want to check whether our web server is up and running, right? Our web server is up and running. I can just type ping Aurora cs.lk. And yes, it's up and running. Up and running in the sense the machine is up and running, not the web server is up and running. Okay, the machine is up and running. So it's very simple thing. And if now this is I use the domain name. If I know the IP address, I could have even directly ping the IP address. Right? Ping. So just check whether the machine is up. Okay, so this confirms that the machine is up. This confirms that not only machine is up, the DNS resolution is also working in our side, at least in our side, and it's correct. Right? So that is ping, but it does not give you more than that information. You can't use the ping command to find where the issue is. It just check whether there's an issue or not from this end to the other end. It can be if the ping command is not responding or giving errors, there can be so many possible issues. Maybe the server is down, maybe we are not having networking, maybe some intermediary point there's an issue where therefore we can't connect to there. Okay, so many possibilities. And when you ping a DNS name, and if it is giving error, even there's another possibility, maybe your DNS server is down, your DNS server is down. So it adds one more possibility. So therefore, by just looking at the ping command result, you can't decide the reason. Okay. So therefore, if you want to know where exactly the issue is, so then you have to go for trace route. Trace RT. Okay, trace TRACE RT. Say I can use the IP address or I can use the domain name. Okay, let's use the domain name. It will take a little bit time, but definitely it's going to tell you more information, and it will show you, okay, my data packets managed to reach up to this hop, but from that hop onwards, I'm not getting any response. So that means the issue is at that point. Okay. Of course, for this one, we are not going to get any data packet losses because our ping command also gave us the correct results. Here you can see they are sending 4 data packets and check whether all 4 data packets are getting the round trip. Right? If none of those data packets are getting the round trip, that means definitely serious issue. But if some data packets are lost, that means mostly some network traffic and other issues. Okay. Right. So therefore, trace route has more. Now you can see it has reached some servers in the USA. Right. So now it's definitely in our server side because our server is hosted in shared hosting in a US server. Right. So this gives you more details. Right? This gives you more details. And after sometimes it will say, okay, completed. Okay, maybe this may be the last hop. We'll come back to that later because it's now I think it's done. Okay, so that is how the trace route happened. And of course, there are so many tools which gives you even the visualize view as well. We call them visual trace route softwares. Okay, right. Now, what are the, now the question is, what is the protocol used for trace route? If when you are using the trace route utility, which is, what is the protocol used? Definitely it is not HTTP or SMTP or something like that. Okay, so remember this one is, so pay special attention this one, because this question, there's a highly likely this question will be repeated. Okay, so the answer is ICMP protocol, right? ICMP protocol. So just make it a note, because I think it is not mentioned in your note. Just double check. I can't remember, but it was in, I think it was in the old syllabus or all note. Whether it's in the note or not, if it is mentioned in your reference book, or if it is something that is important, you must know. Okay. Now these are very sort of a favorite questions in network papers, right? What is the protocol behind trace route? What is the protocol behind domain resolution? What is the protocol behind ping command, etc. Okay, right. 11. Which of the following protocol can be used to discover the MAC address of an interface with a given IP address in a LAN? So that is a very straightforward question. We discussed that. That is what? Address resolution protocol, right? ARP. Given the MAC address, it can check the IP. Given the IP, it can check the MAC address. Of course, the DHCP is used to dynamically assign an IP address to a host. Okay. Post office protocol is for the email. Download email from your mail server to your machine. Ethernet protocols are very low level than protocols. Okay. Actually, they are not really protocols. And DNS protocol is used to domain name resolution. So this is address resolution protocol, ARP. A. A. Right, 12. Now this question is again, pay special attention. If possible, right? For this subject, I am not asking this to all the subject. For network subject, do at least 10 years of past papers, especially MCQs and go. Of course, you may be getting some questions which you may not be able to answer. That is fine, because the syllabus has been changing. But if you can do 10 years of past papers within this week and next week and go, guaranteed you don't have to go to the network paper in the 2022 again. 2023 in your case. Okay. So make sure you don't go to the same exam paper twice, right? Of course, you are the, I will always call you the unfortunate batch, because you are under a lot of stress, because they are publishing the content at the very last moment. Not only you, even we are under pressure also, right? Sometimes in the morning I see the note, and in the evening I have to do the topic, right? Because these subjects are highly technical subjects. Okay, right. Anyway, so what is the most abbreviated form of the following IPv6 address? So this is very famous question. Okay, these things are now in even the A-level ICT syllabus. So remember, in IPv6 we have hexadecimal numbers and separated by not dot but colon. How many portions are there? 1, 2, 3, 4, 5, 6, 7, 8. But when it comes to writing those numbers, if there are 0 blocks, all 0, okay, all 0 blocks, we can abbreviate. How do we abbreviate? We just take, say, 7001 colon, then you write the rest of the stuff, right? So then how do you know how many these sets are there? Because we know that all together there are 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we know that there are, because colon and we have 1, 2, 3, 4, 5, 6. Then we know that this colon represent 2 set of 0, 0, 0, 0 and another 0, 0, 0, 0. Right? If this is also 0, we will be writing 3 colons. sorry, then also we are writing 2 colons, always 2 colons, sorry, but then there will be less, because this is also 0, then our next one is 0, 3, 2, 1. Then we know that, okay, there are only 5 values here, and therefore these 2 colons represent 3 set of zeros. That is how you do it. Okay. And then someone will ask, if you don't understand, just let me know. I can explain it again. Don't worry. Right. So what happens? What happens if our IPv6 address is something like this? Say 7001 0000 say 1000, then again 0000. Just I'm writing a number 1 2 3 4 5. You need 8. 1 2 3 4 5 6 7 8. Say 1820 011B 1 2 3 4 5 6 7 and 1120. Okay. And now how can you write this? How can you write this? Because here also we have zeros. Here also we have zeros. So here what we do is we abbreviate the first set. So that is 7001 colon 1000. Now someone will ask, can't we write here also colon to represent this? Assume this is also 0. Can we write again colon? No. We can have only one place we can have it, because otherwise we don't know whether it is 1 and 3. Say we have only 6, we have only 4 now. We have only 4 portions. Now we know that these things are representing another 4, but we don't know whether that is 2 2 or 1 3 or 3 1. So therefore you can have only one set of colon. So therefore these zeros you have to write. Right? These zeros you have to write. Okay. Even this 0 you have to write. The only place you can have it, because then only we can guess how many 0 blocks are represented by that. Okay. Anyway, in this case you don't have that issue, but in your paper maybe they will give something like that. So don't write colon here and also colon here, because then it's ambiguous. Right. Now we have only the here, so therefore 7001 2 colons, then rest of the stuff. Do we have that answer? This is not the answer. 700, this colon 1, no. Then you must have not 3 to 1, right? It must be, no, these zeros are different, because this 0 belong to this and these zeros are here, and also this is not all zeros, there's a 1. If it is all zeros only, we can block it. So therefore this is wrong. This is correct. 7001, and this block is represented by this. Then the rest of the stuff is just written as it is. So this one is there. Okay, this one is there. So the answer must be E. Right. Answer must be E. Okay. Pay special attention if you have more than one block. Only one block can be represented. Other blocks you have to just write as it is. Okay. E. 12E. 13. Right. So this is also some important question, popular question. That is, now remember we have the old IPv4 addresses and new IPv6 addresses, and they now coexist. We are in a transition. You can't just go from V4 to V6 like switch off and switch on another one, because there are so many routers in the world which are all routers which has no idea about V6, and they can't say replace your all routers before this date. So therefore now the data packets are carrying some data packets V4, some data packets V6. Okay. In certain part of the networks, they cannot understand. They can understand V6, but here it can understand only V4. Therefore, what we got is a V4 address. Now it has to be converted to V6. And also the vice versa. Right. So therefore, how can we convert V6 and sorry V4 address to V6. So what we do is we just take it to the last portion, because we have 8, right? We have 8 components, right? We have 8 components. So therefore, what we write, how do we write it is, we just take lead in zeros. It's something like 0, 0, 0, 0, 0, 0, 0, 0, blah, blah, blah. So then we take the 8 blocks. Then we take the 8 blocks. Okay. So that is how you write the thing. But at the same time, we don't write the colon. We just write the normal dotted notation. So therefore, this will be translated to 2 colon marks, then 8, 8, 8, 8. Okay. So that is how V4 address is converted to a V6 address. Okay. So that they can ask that question again. Okay. So this is a IPv4 compatible IPv6 address. Okay. Right. So 13 answer must be okay. Sorry, I got disconnected because of the power transition. Okay. Now I'm connected back. Okay. Right. Hope you can hear me again, because there's a power transition. Right. So 13. So the answer must be D. Okay. So your IP address will be in the right hand end. Okay. Right hand end. And it will be the dotted, that block represent that they are all zeros. Leading 4 octals are all zeros. Okay. Right. 14. Which of the following is not a field in the IPv6 fixed header? Okay, so this is now, earlier we were talking about the port or the TCP or the UDP headers. Now this is IP headers, right? In IP headers, what are the things that are not there? Obviously, the source IP address must be there, right? The destination IP address must be there, right? Payload length, the size, I can't really remember. Let's double check that, because I honestly I can't remember it. Okay. Hop limit, I think that is there, right? So the how many hops, or the how do you call it? I think that is called time to live, TTL or something. Okay. And the fragment offset. Actually, I can't remember exactly. Let's double check. Okay. Because I can't remember exactly what are the fields are, because there are so many fields in the IP headers. Let's double check the fields available. Most probably that will be in the network layer topic. Right. IP version 6 header fields. Now I told you that you have to remember these things, unfortunately. Okay. I know that it's a hard thing. Even I can't remember all these fields as a human. Right. The version is there. Flow labels, payload length is there. Next header, hop limit is there. Right. Of course, the source IP address and the destination IP address. Right. Yeah, those things, right? So just remember those things. Payload length, next header, hop limit, source address and the destination address, as well as you have the version as well. Okay. Right. You can see these headers have been removed. So the examiner can ask that this next time, right? What are the headers that header fields they have removed from IPv4 to IPv6. Right? Some checksums, fields related to fragmentation, the protocols, internet header length, IHL. So these things they have removed. Okay. So just make a note of that also, because since they have asked these things in the last year, so they may ask this in this year, right? What are the things that has been removed? Okay. Right. So now I hope you can get the answer. Right. So the answer is E, fragment offset. Right. So hop limit was there, right? Payload length, I think payload length was there. Yes, payload length was there. Hop limit is there. Payload length is there. So the answer is obviously fragment. There's nothing called fragment offset here. Okay. I think fragment offset is in TCP header. At 15. What is the purpose of class D addresses? Now remember, class A, B, and C is used for subnetting. A, B, C is used for subnetting, and class D is used for multicasting, and class E is reserved for experimental and their purposes. Okay, so they are experimental purposes. So therefore, class D is used for multicasting. Okay, multicasting groups, right? So this is so therefore answer is C. Okay, 15 C. 16. The bandwidth of a channel is 1 kilohertz. Right? We did this formula. The bandwidth is given and the noise level is found to be 1/511. That is the signal to noise ratio, SNR. Right? SNR, they have given it in a different format now. What is the maximum possible data rate? Remember, we discussed the theoretical maximum is C equal to B. But in a noisy channel, it is not 2B. It is B log 2 1 plus SNR. If I remember correct. Okay, so B is bandwidth in hertz. This is signal to noise ratio, and what we get is a capacity in bit per second, BPS. Okay, let's double check whether the formula is correct, because I just write it with memory. It must be in your physical layer. Yes, physical layer. මේ අලුත් සිලබස් නෝට් එකෙත් මේ ටික තියෙනවා හරි. මේක පරණ සිලබස් පේපර් එකක් මේ කරන්නේ එකක් මත තියාගන්න. So that means you can do almost everything, more than 99%. බලන්න. Right, so this one, right? So this is for noiseless, right? 2B කියන එක ඔයාලට දීලා නැහැ අතන අලුත් සිලබස් එකේ. For noiseless, remember your channel capacity is 2 times B. Okay. Mean 2B log 2V කියන්නේ අර number of levels වලින් ඔක number of levels 2 නම් log 2 is 1. So the maximum data rate is theoretically 2B in binary. If you are sending binary data, obviously we are sending binary data, so therefore V is 2, log 2 is 1. So channel theoretical maximum capacity is 2B in a noiseless channel. Okay, so that is called the Nyquist bandwidth. But in noisy channel or the realistic channel, so it is log 10 SNR is actually, it's not log 10, it is log 2 if I can remember. Okay, that is if it is a decibel, log 10, but otherwise it is log 2. Okay, log 2 කොබන්න මෙති එතන කොහොමද log 10 දාලා තියෙන්නේ ඒ ඇවිල්ලා මේ මොනවයින් දැම්මොත් decibel වලින් ආවොත් right. So that is if it is decibel, log 10. If the signal to noise ratio is given in decibel, you use log 10. But if it is not in decibel, just they have given it as a fraction, So then you have to use log 2. එක පොඩ්ඩක් මාක් කරලා තියාගන්න. අර එක දැනි මීටරුනේ එකපාරට ෆෝමියුලා දෙකම අලුත් එකේ දීලා තියෙනවා. Right? So if it is just your signal to noise ratio, not in decibel values, right? So you have to say B log 2 1 plus signal to noise ratio this SNR. Okay. And what you get is bit rate, bits per second. Right? In both the cases, what you get is bit per second. Have I may avilla? නෑ මේ දිය තියෙන SNR එක හරියට sorry මේ දිය තියෙන SNR calculate කරන විදිය හරි. So either you can take it as S divided by N or log 10 S divided by N. Okay. Or you can even give it as 10 log 10 S divided by N. So අර ගොඩක් අය මේක දෙනවා SNR එක දෙනවා අර SNR calculate කරන්න දෙන්නේ නැහැ. හැබැයි මේක calculate කරන්න මොකද දෙන්න හේතුවක් නැත්තේ මේක එක එක විදියට calculate කරනවා. SON කියලා දෙනවා log 10 SON කියලා දෙනවා 10 log 10 SON කියලා දෙනවා. අදන්නේ නැහැ කොයි එකද පාවිච්චි කරන්න කියලා. So therefore this is the SNR formula. Okay. So in capacity formula is log 2. It's very important. Log 2 1 plus signal to noise ratio. Okay. Right. So what they have given you the signal to noise ratio. Right. Signal to noise ratio. Now let's get back to your question. Right. So this formula is correct. Okay. The bandwidth of the channel, that is this one. You have to write it in hertz. It's very important you have to write it in hertz. This question is almost every year. If you look at last 10 years of the past papers, I would say out of 10, at least 7 years, they have a question that you have to use this formula. Okay. So that is why I asked you to do as much as possible past papers. Right. And you have to write it in hertz. So therefore, this is 1 kilohertz. Remember, when you are converting hertz to kilohertz, it's not 2 to the power, it is 10 to the power. Okay, because this is not a bit byte concept. Hertz is normal concept. So therefore, this is 10 to the 1 into kilo. Kilo means 10 to the power 3. Okay, so then log 2 1 plus. Now they have given you that. But they have not given you the exactly SNR ratio. What they say is noise level is found to be 1 over 511 times that of signal power. Okay, 1 over 511 times that of signal power. What is the meaning of that? Signal to noise ratio is 512. ඔය කියන්නේ ඒකයි. හරි? Signal to noise ratio එක 512යි. මොකද signal එකේ strength එක වැඩි වෙන්නේ by noise එකට වඩා කොහොමද නේද? ඒ කියන්නේ noise එක 511න් එකයි කියන්නේ signal එක තියෙනවා ඒ වගේ 512. So therefore what they have given is indirectly they are saying that SNR is 512. හරි මේ ගොඩක් අයට කෙලින්ම දෙනවා SNR එක මෙච්චරයි කියලා මොන ඔය අවුරුද්ද තමයි ඉස්සෙල්ලා මේක වෙන විදිහකට දීලා තියෙන්නේ. So therefore this value is 5 මේක කියන්නේ 511 ගුණයක්. 512 නෙමෙයි 511 නේ. So that means your signal to noise ratio is 511 times. හරි. එකට 511යි කියලා අය කියන්නේ. හරි. 511යි. This is so or otherwise 511 to 1 signal to noise ratio. Signal එකේ strength එකෙන් 511කට එක strength එකක් තියෙන noise. So therefore SNR is 511. ඔක සුළු වෙන්න දෙන්න ඔයාලට. හරි. එක්සෑම් එකෙත් බය වෙන්න එපා සුළු වෙන්න දෙන්නේ. නැත්නම් ලඝු බලන්න බෑනේ ඔයාලට දෙකේ පාදේ. So therefore final answer is 1 plus SNR is what? 511. ඔක අන්තිමට 512 හැදෙන්න දෙන්නේ ආ. 511 එකයි 512යි. So that is 10 to the power 3 into log 2 512. 512 කියන්නේ අපි දන්නවා ලඝු දෙකේ පාදයෙන් ගානක් හොයනවා වැලියු එකක් හොයනවා නම් මේක දෙකේ බලයක් විදිහට ලියනවා නේද log 10 is 1 because 10 to the power 1 log 10 100 is because 100 is 10 to the power 2 it is 2 right log 5 25 is because 25 is 5 to the power 2 it is 2 දැන් එහෙනම් log 10 512 කියන්නේ මේක දැන් දෙකේ පාදයක් විදිහට ලියුවා මේ බලය තමයි උත්තරේ. So that is 512 is 2 to the power 8. Well, 2, 4, 8, 16, 32, 64, 128, 512. Yes. So therefore, if you can write it as 2 to the power 8, log 2 to the power 8 is 8. So therefore, 8 into 10 to the power 3 is 8 and 3 zeros. So that is 8,000 bit per second. Oh, 8,000 and 9,000. 2 to the power 8 and 9 here. 2, 4, 2 to the power 1 is 2, right? 2, 4, 8, 16, 32, 64, 128, 512. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9. Sorry. 2 is 2 to the power 2. 2 is 2 to the power 1. 2, 4, 8, 16, 32, 64, 128, 512. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1, 9. 9. 8 plus 1 in 9. It looks like it must be 8,000, right? Not 9,000. Because this is 2 to the power 8. 2 to the power 1, 2 to the power 2, 3, 4, 5, 6, 7, 8. I think, what is the answer? I think the answer is they have given it as 9,000. Let's double check the answer. 16. Yes, they have taken it as 9,000. Just double check, okay? Because the formula, according to the formula, it must be 8,000, not 9,000. 512 plus 1, 5. 511 plus 512. Okay, 512 එන්න තමයි ඔයගොල්ලෝ දෙන්නේ කොහොමද? Just double check. Okay, I will also double check. The given number is 9,000. I don't know whether it's a mistake by the examiner, but what I got is 8,000. Okay, because 512 is 2 to the power 8. So therefore 8 log 2 to the power 8 is 8. 8 into 1,000 must be 8,000. Okay, but the answer says 9,000. Anyway, I will also double check. Okay, maybe mistake in the answer sheet. Right. So 17. What is the Hamming distance? And we discussed the Hamming code last, I think we discussed it in last Wednesday also, right? Remember? So the first location, second location, fourth location, 8th location, 16th location, 32nd location, right? So 2 to the power n locations are used as Hamming codes. Using the Hamming codes, we can identify if only one single bit corruption, we can say exactly this bit has been corrupted. And of course, if it is 0, then it has to be 1. If it is 1, it has to be 0. And I gave you some examples, okay? How to calculate that, right? First, how to calculate the Hamming codes. Then if you get the output or the data with Hamming codes, check whether is it correct. And if it is not correct, check, find out where the error is. And of course, assuming that only one bit is correct. Okay. So therefore, Hamming codes or Hamming distances are related to these positions 1, 2, 4, 8, 16, 32, etc. Okay. So it is a number of positions which the two codes differ. Distance between 2 points in network, definitely no. Number of ones in message, no. It represents the weight of code word, no. It is the number of bit errors in a message, no. It is the number of positions in which code words differ. I think that is correct, right? So the code word differ කියන එක තමයි මේ එන්නේ position වලින් 1 2 4 8 16 කියලා. ඒගොල්ලෝ හරියටම කෙලින් කියලා නෑ. නමුත් differ කියන්නේ මේ position එකයි මේ position එක අතර වෙනස, මේ position එකයි මේ position එක අතර වෙනස තමයි කියන්නේ. වටෙන් කියලා ඇත්තේ ඔක තමයි. Right? Let's double check whether that is the answer first. Yes, හරි. Code words differ කියන්නේ මේ position දෙක අතර තියෙන වෙනස තමයි. 2 minus 1, 4 minus 2, 8 minus 4, etc. Anyway, I explain you how to calculate the Hamming codes. Okay. I think we discussed that not Wednesday, maybe last Monday. Okay. Right. Recording aram balanna. Hari Hamming codes මතක නැති මොකද ඔය අලුත් සිලබස් එකේ Hamming codes explain කරලා තියෙනවා පවා. ඔය එකේද අපි කරේ ඒක network topic එකේ නේ. No transport. නෑ ඒක කරේ අපි data link layer එකේදී. Hamming yes Hamming codes. Hamming codes හදන විදිය දැනගෙන ඉන්න ඕන. ඊළඟට second paper එකේදී question එකක් අනිවාර්යෙන් maybe you get it. Hamming codes හොයන්න. හරි Hamming codes හොයන්න. I did examples on that. Right. So this one. Maybe in Hamming codes calculate. So the first location, second location, fourth location, 8th location, 16th location, etc. So I explain you how to calculate these Hamming codes values, and also when you get something like this and check whether is it correct or where the issue is. Again, assuming only one bit has corrupt. Okay. So we call them parity 1, parity 2, parity 4, etc. Okay. Right. So you can refer to that session. Okay. How to calculate the Hamming values, Hamming code values. Right. 18. Which of the following statements regarding twisted pair cables is not correct? Right. Not correct. Right. We know that the twisted pair cables are used for, especially for local area networks, and also very rarely long distance net. Long distance we use mostly fiber optics. Okay. And also we have category 3, category 4, category 5, 5E. Higher the category number, higher the quality. Right. So usually high speed, right, gigabit, Ethernet, etc. We go for higher categories. And also when you go up the higher categories, you are moving from unshielded twisted pair UTP to shielded twisted pair STP. Okay. Right. So let's read the answers. Category 5 cables have more twist per inch than category 3. Yes. Higher the number of twist, higher the quality. Higher the number of twist, higher the quality. And of course, higher the number in your category is also higher the quality. That is obvious. But it's not only the number of twist, it is the quality of the copper, it is whether you shield or unshield. So all those things counted for a higher data rates. Okay. Category 5 cables have more bandwidth than category 3. Yes, obvious. So more bandwidth means you can use it for faster communication. Yes. Twist in the cables reduce external noises. Yes. So why we are twisting? To reduce the noise, right? Reduce the noise. It's mentioned in our note also. Okay. ඔයගොල්ලන්ට ඒකට අපේ note එකනේ දුන්නේ. ඒතකොට ඒ note එකේ තෝග ඇති. මොකද පරණ සිලබස් එකේ මේක මෙහෙම තියුණා. Twisted pair cables are used for electrical wiring to carry high voltages. No, right? So have you seen that the twisted pair wires high voltages? So that of course we are using some sort of a twisted wires, but I don't know whether we can call them also twisted wires. සාමාන්‍ය ගෙවල් වල අපි wiring කරනකොට පාවිච්චි කරන්නේ නැහැ twisted wires නේද? අර එක තැනක ඉඳලා තව තැනකට temporary wire එකක් අද ගන්න ඕන නම් අර twisted wires පාවිච්චි කරන්නේ. So therefore high voltage වලට මේක හරියන්නේ නැත. කොහොමත් ඒක අපේ network වලට දාලා නැහැනේ මේ කතන්දරේ නේද? Twisted pair cables are used in public switch telephone networks. PSTN වල ඔව් අංක ටෙලිකොම් වලත් විශේෂම ටෙලිකොම් එකේ පවා තාම අර කණු වල අර පොළොව යටින් යන වයර් විදියට මේගොල්ලෝ පාවිච්චි කරනවා twisted pair. මොකද තාම අපි 100%ක් fiber optics වලට ගිහිලා නැහැනේ. ඒගොල්ලෝ තාම ඔය ළඟ communication wire අදිද්දි පොළොව යටින් යන අර වයර් වල ඔයගොල්ලෝ දැකලා තියෙනවා අරපු වෙලාවක නැත්නම් අර කැබිනට් එකක් අරපු වෙලාවකට ඒවයි තියෙන බොහෝ විට twisted pairs තමයි. හරි. So that is correct. So other than in LAN local area networks, even the telecom providers also can use twisted pair wires. Okay. Right. So the answer must be not Tewahanne D. Okay. Yes, D. Okay. 19. Which of the following statement regarding 802.11 network is correct? So 802.11 is predominantly used as Wi-Fi, right? Wireless fidelity networks. It can be used for other purposes as well, the 802.11 specification or the standard, but it's dominantly 802.11 is Wi-Fi. Okay, so we discussed that under data link layer, right? Yes, data link layer or the physical layer. I think physical layer. Okay. Then it must be, yeah, ISM bands and those things are here. So ISM bands means the frequency ranges we use. Okay. Maybe the other one. Okay. Maybe data link layer. Yes, I think it's a data link layer. Yeah, IEEE 802.3. Sorry, 802.11. This is Ethernet. 802.11. Yeah, wireless LAN. It's a wireless local area network, right? So you can use it for Wi-Fi and some other things as well, right? Remember we discussed about the infrastructure mode, ad hoc mode, right? Wireless local area networks, right? You can see these are some usages. 802.11 short range radios, so that is 2.4 gigahertz of 5. So then yeah, so that is Wi-Fi CSMA CA is used. Again, it's 802.11, right? Right. So it's pretty much used in local area networks mostly, and also some related places. Okay, right. So this is anyway a little bit difficult question because they check whether you have memorized those things. 802.11 networks can operate only 5 gigahertz ISM bands. I think they mentioned something about the ISM bands, but I can't remember actually. Honestly, I can't remember all those things. Okay. ISM bands. You can see 802, 2.4 to 5 gigahertz. This is 54 megabits for 5 gigahertz, right? I think 5 gigahertz looks like the highest value. Right, so 5 gigahertz looks like the higher value. Anyway, GSM networks also operate in the same frequency range as 802.11 networks. I don't think so, because 802.11 is for short range, right? Something like local area networks, personal area networks, etc. Okay, so GSM networks means the mobile providers. Okay, I don't think they are using these standards. Okay. Bluetooth networks do not interfere with 802.11. Now, Bluetooth is also used for local communication. So therefore, there's a possibility of, I think there's a possibility of, because I can't remember that Bluetooth has a different specification. I think they are also share in this the same specification. Okay. They say do not. So therefore, I will say no. There is a possibility of interference. Wi-Fi and 802.11 networks do not operate in the same frequency range. Right? I told you that Wi-Fi is the main technology that use the 802.11. So therefore, definitely Wi-Fi must be operating in the same frequency range. And this says do not. Okay, do not. So therefore, we'll say no. Garage door openers also use the same frequency range as 802.11. අපිට හම්බුණා නේද garage door openers කියන වචනයෙන්ම අහුණා මේගොල්ලොත් ඒකම තමයි පාවිච්චි කරන්න කියලා මට මතක නැහැ මොන ස්ලයිඩ් එකේ හරි මේක හම්බුණා. This is correct I think. Okay. ඔය විදිහටම note එක තියුණා. I can't remember exactly which note. Okay. අන්තිම හරිය note එකද ඔය තියුණා නේද? Anyway, this is all syllabus question, but not this one. Is it this one then? Where's the very last? You can see ISM bands. You can see garage. These are the technologies: garage door openers, cardless phones, radio control toys, Wi-Fi, Bluetooth, microwave. So they are all part of that. So these are ISM bands. Okay. So these are the different ISM bands. Different ISM bands are utilized by different usages. Okay. But there's a possibility of interferences as well. Okay. Right. So therefore, we'll take that one. Okay. Garage door openers also use the same frequency. Yes. So that is correct. That is correct. Can operate only in 5 gigahertz. Is it the case? Only in 5 gigahertz? No, right? So it can go for different frequencies as well. The garage openers are left. Right. So there are some other frequencies as well. Okay. Even 2.4, right? So there are some other ISM bands are there. So therefore, let's not take it as answer. So therefore, the correct one is E. Okay. Yes, C. Okay. At 20. Consider the following statements regarding wireless networks. RTS CTS protocol is used as a solution to the hidden station problem. We discussed the hidden station problem in the wireless network. We discussed two problems, right? Problem. One is hidden station problem. The other one is
export station.
Sorry,
problem.
Can you repeat that?
Export station problem.
Yes, expose. Yes, expose station. So that is unnecessarily exposing to you some other collisions, possible collisions. Yes. So those are the two problems. Which topic did we discuss that? I can't remember the topic number. Is it network management or no? Right. I think it is again data link layer. Yeah, hidden terminal problem and the exposed terminal problem. So hidden terminal problem means you are not directly aware of that existence of the other terminal. Okay. For example, because they can ask these questions again. Consider the figure A and C wants to transmit A and C. So there is A here, C here. A and C wants to transmit to B. But A and C is not directly aware of B. Right? C is aware of D, B is aware of A. Right? So you can see that they are not directly aware of each other. So therefore, if A is transmitting, right? A is transmitting, C cannot sense it through it sense in the medium. Let's read it again. A and C wants to transmit to B. A and C wants to transmit to B. Sorry, this is the problem here. Okay. A and C wants to transmit to B. A want to transmit to B. C want to transmit to B. Okay. If A is transmitting, C cannot sense it through sense medium because C is not directly connected to A. Now again, I will delete and show it again. Right? You can see that this is the A's territory. A is aware of B and B is aware of A. At the same time, B is aware of C and C is aware of B. But A is not directly aware of C. C is not directly aware of A. A is aware of B, B is aware of A. C is aware of B and B is aware of A. But A and C are not directly aware of each other. So that is called a hidden terminal problem. Okay. For example, if A send a data to M or the B and C send the data to B, there's a possibility of collisions, right? At B. So that is called hidden terminal problem. Okay. So then what is mean by exposed terminal problem? Right. So this is exposed terminal problem. Consider the figure B. Now this is explained in the exposed terminal problem. This diagram is for the hidden terminal. B needs to transmit to A and C. B need to transmit to A and C. Okay. B need to transmit to A and C need to transmit to D. B need to transmit to A and C need to transmit to D. Okay. If C sends the medium, while B is communicating with A. Now B is communicating with A, right? But it has nothing to do with C communicating with D because C has to communicate to the other side. But C can sense this communication, which is not relevant to C and D. C communicating with D, but anyway, C can sense it, right? C can sense it. C sense the medium is already in use. So therefore, C feel like the medium is already used because actually B is communicating with A. But that is this side. What you want to send is that side. But actually that side is vacant. It's not used. But you are exposed to some other communications, which is not relevant to your communication if you are only communicating with D. So that is called exposed terminal problem. Okay, because when the bandwidth is available, right, still you are not communicating because you feel like the media is busy. Okay, so that is called exposed terminal problem. Right, so here also they have not mentioned, I think, solution for that, but the examiner has asked what are the solutions for those. Maybe it's there, right? You can see the problem solutions I have mentioned. Protocols use request to send and clear to send frames as a solution for the problem. Actually, it is not a protocol. So they can use these concepts. So they are protocols, right? Oh, it is protocol use. No, protocol use the request to send and clear to send frames as a solution for this. Okay. Are they mentioning about a particular protocol? No. Okay. Now, what is the question asked? Yeah, request to send, clear to send. Okay. Actually, it is not protocol. Those are frames. Okay. Those are the frames they use. But anyway, they have considered it as a protocol as well. RTS and CTS protocol is used as a solution to the hidden station problem. Actually, they are not actually, I don't feel like they are protocols. They are just this different type of frames. But anyway, shall we take it as answer or shall we not take it as answer? Because your note says they are just special frames. Okay. Anyway, let's keep that as open one. OFDM is a physical layer technology of 802.11. OFD, open, I can't remember what is this. In DCF mode, 802.11 station acts without any central control. I am not very much familiar with these concepts anyway. Maybe because they may ask that kind of questions, right? Advanced concepts questions, so that Otherwise, you will be getting closer to the 100 as well, right? So they want to control number of A's, number of A pluses, etc. Right? I don't know whether this was mentioned in the previous note. I don't think. Maybe those are mentioned in your reference books. Actually, I'm not that familiar with these concepts. Okay. Anyway, what are the answers? D. D means that means all are correct. Right. So they may ask this question again. Just make a note of that. So hidden station problem. One of the solution is use of these frames or protocols. OFDM is a physical layer of technology. What is OFDM? Whether is it mentioned in the physical layer? Physical layer. No, not in the new syllabus. I think even in the old syllabus, it was not mentioned. Right. So anyway, so they have taken all these as answers. Okay. All these as answers. Right. 21. Right. So just let's keep this question 21 because I can't remember the exact formula that has to be used. I think this was there in the old syllabus, but I can't remember the exact formula to be used. And this similar question is there in 2019 paper also. I will take those two questions separately. Okay. Right. 22. What is the binary exponential back-off algorithms? Right. Forget about the binary exponential. We discuss about back-off strategies. So now examiner has make it little bit intimidating to you by giving you sort of a very technical term. But we discussed that in CSMA CD, carrier sense multiple access with collision detection, there's a possibility of collisions. So in case of a collision occur, there are some strategies, right? What are the possibilities? One in n the p probability strategies. Let's open the note. So those are the back of strategies. Right? So we discussed those in logical link, right? Yes, logical link. CSMA CD. Right. So here we discuss the back of strategy somewhere. I think in the new syllabus note, it is not there, but definitely it was in the old syllabus. Yeah, not Aloha. CSMA CD. Here, these are the backup strategies, right? One, persistence. Right? Remember, if there's a collision, they have to wait. Right? If there's a collision, because collisions are possible in CSMA CD, that is why we have to detect the collision. Right? In case of a collision, there are some strategies for retransmit or to detect the once you detect it, there are some strategies. So now you detected that your data is collided. So once you detect it, there are three possible strategies. Okay, what are those three possible strategies? One, persistent, non-persistent, and p-persistent. One, persistent means the channel is busy. If the channel is busy, the station just keep listening to get the first option possibility of available time slot. So that is called one persistent. It's a very greedy approach. The non-persistent means you wait for a random period. If it is right now busy, you wait for maybe 100 milliseconds and then only you again check. If it is again busy, you wait another random time and again check. So that is called non-persistent. That is very generous approach. So then we have the P-persistent, right? You keep sensing, but when you find that it is available, you may use it, you may not use it. So that is called probabilistic, right? Maybe your probability is 0.3. 0.3 of the times you will use that. 0.7 of the time you will not, still you will not use it. So that is called P persistent. So those are the back off strategies. Back off කරනවා කියලා. හරි. වචනේ ඔයගොල්ලන්ගේ note එකේ නෑ, but our note, I think we use that word. You can see, yes, we have used that word, wait according to the back off strategy, right? Because the all syllabus, they had mentioned that very specifically, the word, right? So we have to wait according to the back off strategy. What are the back off strategies, right? So these are the back off strategies. Non-persistency is one persistent and a P persistent. Actually, our note has very clearly mentioned, right, than your UCSC note, because UCSC note is very brief note. Okay, so those are called what? Back off strategies. Okay, right. So now let's now we got the answer anyway. Right, what is the binary? It is a procedure used in CSMACD networks to avoid collision. Yes, right. So it is in a way we try to avoid collisions, but anyway, let's see whether there's a better answer. It is a binary encoding system. No. It is used by ISPs to rate limit. No. It is a compression mechanism. No. A technique used to increase data rate. No. Yes. So we can say it's sort of avoiding. That is why we wait, back off, right? Wait for random period, or we don't take all that opportunities. Probabilistically only we take. So that is to we try to be nice, right, with other communications. Okay. Yes. So yes, that is the closest answer. Right. 23. What is the purpose of 4A record in DNS? So this one was specifically mentioned in your note also, your VLE note, new syllabus note. I think that is in network management, right? The DNS entries, A. ඊට කලින් එකේ application level නේද? අපි DNS යන්නේ application level protocol එකක් විදිහට. Yes, this one. ඒක අලුත් syllabus එකකට තිබුණා. හරි. ඔයති. So මේ ටික හොඳට බලා ගන්න මම වෙදත් කොමෙන්ට් එක ඉතා වැදගත් කියලා. So AAA is IPv6 address of the host, right? IPv6 address එක වගේ domain name එකට අදාළ මොකද your DNS server, you have to configure this domain name is mapped to this IP address, and this is the most important. If it is single A, IPv4 address. If it is 4As, IPv6 address. Okay, so then some other things also you will have to බලාගෙන යන්න. මොකද මේ question එක අපිට වැදගත්. right? So මේක තමයි ගොඩක් අයට අපේ web server configure කරන්නේ DNS එකේ. Then MX entries are for email servers, right? MX entry is the IP address of your email server, right? You can even have more than one email service also. This is for the name servers, right? This is another way of giving your domain name to, if you want to match it to another server, right? So this I told you just to give a text, right? What put text එකක් දාන්න ඔයාගේ domain එක verify කරගන්න එහෙම කාට හරි ඕන නම්. හරි ඔය ටික තමයි වැදගත්ම ටික. MX CNAME TXT වගේ වද අපිට වැඩිම වැදගත් වෙන්නේ උතන. හරි. So this is an alias to PTR also is also important. That is alias for another IP address. It's not really a domain. Okay. Right. So therefore now we can find the answer. Question. Close කරාදමු. Close කරන්නේ. Let me open it again. Right, so it's a 4A records given no. Yeah, it's a IPv4 address, right? The record A maps IPv6 address. Okay. Anything else is correct? It is a 4A no. It is indicate domain name no. It's a record type A map for no, IPv4 no. It is record reserved for future use no. Answer must be D. Okay, 23D. Yes, D. 24. Which of the following statements is true regarding ADSL service? Right? Asymmetric digital subscriber line. In Sri Lanka, the DSL technology that we use is ADSL. And most of the countries it is ADSL. Why we call it asymmetric? We give higher bandwidth for download and smaller bandwidth for upload, because general users do more download and less upload. But when it comes to fiber optics and other things, the upload and download bandwidth is pretty much the same. Okay. Now I am connected using wireless actually. Actually, I am not using ADSL. But definitely if you have ADSL connection, you will find that if you do a speed test, right? If you do a speed test, of course, this is now I am, because of the power issue, I am using my mobile connection. So here also the download speed bandwidth is much higher than upload bandwidth. Right, you can see the download bandwidth is somewhere around 30s, but my upload bandwidth is going to be somewhere around 10 to 20, because that is what we need. But in ADSL, that is sort of a specific limitation. Here it is, they configure like this. Okay, here they just configure like that. But in ADSL, that is the case. But if you take the fiber optics, pretty much upload and download is very close to each other. Okay. Right. You can see upload is 16, download is 30. Anyway, this is not ADSL connection. Okay. Right. So what is the answer therefore? ADSL provides very high upload bandwidth compared to download bandwidth. Definitely wrong. Okay. This is they are talking about the ADSL as well as category 3 local loop. Category 3 local loop means the normal your telecom providers connective connection. Okay, category 3 can samanya wire. It is highly unlikely that electrical interference affect ADSL. Obviously, ADSL can be interference, right? Because ADSL is electromagnetism through copper wire. So electrical interference is not there for fiber optics, right? Not for ADSL. Unlikely, so therefore wrong. So for fiber optics, no electrical interference at all, right? Thundering, motors, right? Any other vehicle going by, they are not going to interfere. The bandwidth of the local loop drops with the distance from the exchange. So that is a very famous point, right? In ADSL, if you are close to the ADSL point, you get a higher bandwidth. But if you are far away from ADSL point, you get a very slow internet connection. That is one of the biggest disadvantage of ADSL. So therefore, the people who are close by the main roads get high speed. If you are in a lane far away, you get a slow internet connection. So that is the biggest, one of the main disadvantage of ADSL, which is not the case for fiber optics and other things. Okay. And of course, for mobile wireless communication also, if you are close to the tower, you get a higher bandwidth. That is also there. But usually that is not a big issue in fiber optics. Okay. So therefore, this is correct. It is highly the bandwidth of the local loop drops with the distance from the exchanges. ADSL is the best option for host a web server. No, why? In ADSL, you have high download bandwidth and low upload bandwidth. So if you are a web server, you have to do the upload. People are requesting from you. So therefore, ADSL is a terrible option if you are hosting. Okay. So then you better go for fiber optics, because fiber optics, we get a very high, at least the same sort of a bandwidth, upload and download. Service providers have to lay new high capacity cables to replace the existing local loop to provide ADSL. No, right? So ADSL, you just use the normal wire, right? You don't need special wires for ADSL. So therefore, let's take answer as C. C. 25. Consider the following statements. Which of the above statement is not correct? VLAN supports in switches is required to deploy virtual private network, VPN. Now VPNs are, we used to just connect to say I have my office is in this site and I'm using public internet. I want to connect to my office network to do some official work. So then we can create a VPN connection. Right? VPN, of course, here they have to configure the VPN connection and given me the access. Right? So no need to have VLAN. VLAN is a separate concept. Virtual LAN means you are not supposed to be physically separated to create different LANs. So that is the traditional local area networks. You are just one network, right? But logically you are separated. So that means, say these are 4 buildings. Say you can connect to your local area network regardless of whether you are in this building or that building or whatever, because as a logic only, there are different ways you can create virtual LANs. You can identify whether you are belong to virtual LAN A or B or C or D by your IP address or by your MAC address, or there can be different physical ports available. So if you want to connect to LAN A, you have to connect, say, LAN A port. Maybe LAN A ports are here. And maybe LAN B, virtual LAN B ports are also here, everywhere. So then if you want to connect to the LAN B, you have to connect to this one if it is wired. But that is very old approach. The new approach is, they will identify whether you belong to virtual LAN A or B or C or D or E by looking at your MAC address. Right? A MAC address, A virtual LAN වලට දාලා තියෙන. එතකොට ඔයාව අඳුර ගන්න මෙයාව දාන්න ඕනේ මේ virtual LAN එකකට. ඔයාට physically එහෙම connect කරන්න ඕනේ නැහැ. මොකද දැන් ඉස්සර තමයි නේද? HR department එක මෙහි finance department එක මෙහි කියලා හිටියේ. එතකොට මේක ඇතුලේ තමයි ඔයා නිතරම ඉන්නේ. දැන් එහෙම නෑ. ඔයා මේ හැමතැනම යනවා. මෙහි ඉන්න අතරතුරත් ඔයාගේ network එකට connect වෙනවා. Right? So therefore we prefer VLANs. And then කොහොමද හදන්නේ VLAN සමයි. හරි physical LAN වලට වඩා. Right, so that's it. So our following question is but you have to look at the other answers. So therefore first one is wrong. It is always possible to replace network address translation NAT by HTTP proxy. Network address translation එක අපිට proxy server එකකින් proxy server can do some task of network address translate as well, because proxy server can also map your old IP, your internal IP, your private IP to your public IP, but we can't say always, right? Because some features, I don't know. I'm not very sure about this, okay? Whether we can always possible, because not every HTTP proxy server provide the NAT functionality. That is the issue, right? So some HTTP proxy servers provide the NAT functionality because they are two different things, okay? So therefore, I'm not very sure whether we can use always, but that is possible. Right? Only addresses from private IP blocks can be assigned to machines in VLAN. VLAN වල දෙන්න පුළුවන් private IP address විතරක්. එහෙම එකක් නෑ. හරි public IPs දෙන්න පුළුවන්. හරි public IPs දෙන්න පුළුවන්. එහෙම උනොත් එහෙම නැත්නම් ප්‍රශ්නයක් වෙනවනේ. නේද? මට මතක විදිහෙන් නම් පුළුවන්. Right. So this will say no. Always කියලා තියෙන හන්ද. I'm not very sure. Anyway, I'm not very sure about this answer. Okay. Let's look at the answer. Anyway, it's a fuzzy question. Answer they have taken is D. Again, ඔක්කොම wrong කියලා අරන් තියෙන්නේ. Yes, ඔක්කොම wrong කියලා අරන් තියෙන්නේ. Make a wrong anyway. Only addresses from private IP address can be assigned cancel, so that must be wrong anyway. They can private විතරයි කියන්නේ එහෙම ගන්න නෑනේ. So anyway, they have this is anyway wrong. Okay, VPN and VLAN is two different concepts. So they have taken this also wrong. Hari ekena always කියලා තියෙන හන්ද wrong කියලා අරන් ඉන්නේ. Yeah. Yes, so they have taken all these answers as wrong because 1, 2, 3. So that means මෙතන නම් අර always කියලා තියෙන හන්ද මෙතන private කියලා තියෙන හන්ද මේ දෙක සම්බන්ධයක් නැහැ. මේ දෙක ටෙක්නොලොජි කතන්දර දෙකක්. හරි. So therefore that is definitely wrong. Right. So we'll take a small break. I did it slowly because this is the first question paper that we did. Okay. Other paper I am going to do very fast. Okay. Right. So we'll take a small break and do the second paper. Second paper doesn't take much time. Okay. Don't worry. Okay. We'll continue. Right. So now we have moved to the second paper. Right. So here you have two questions, right? Just two questions you are getting and you have to answer both. So 3 questions are there. You have to answer all 3 questions, okay? Right. And also once you do at least 3-4 past papers, you will find that no, that is not difficult. Almost every year you are getting sort of the same type of questions, okay? Right. So this is question number 1. So let's read the question and pay a lot of attention, give serious attention to each and every statement, okay? So that is very important. Right. Consider a network depicted in the diagram above. So this is a network. So you have, this symbol is router, 2 switches and just 1 machine in both sides, okay? So that means router means this is one particular network or subnetwork, and this is another particular subnetwork. Okay, right. Consider the network depicted in the diagram above. R has 2 interfaces. This is our router. Right. R has 2 interfaces. That is this side of this subnetwork and this subnetwork. Okay, 2 interfaces R1 and R2. Okay, so you know that router has interfaces, right? Interface to this network and interface to that network. So maybe 2 NIC network interface cards, okay? Maybe wireless and wired, or both wired, or both wireless, whatever, okay? R1 and R2 It is configured to forward packets between R1 and R2, obviously. Okay. The interface R1 and R2 is configured with IP address. Now R1, this side IP address is 192.168.162/27. Okay, so that is R1. R1 has the MAC address. Obviously, it can have MAC address also. 0800 27 84 64 and E0. 64 and E0. Okay. R2 has the MAC address, that is this side, 0800 27 84 64 and F0. Okay. So this is E0. This is E0. This is F0. Okay. A and B have only single network interface. So that means only one single interface, and here also just one switch. Okay. Right. A and B has only one single interface. A's interface has the MAC address, this one. A's interface. So that is basically, it is interface in this way. Okay. So let's call this, I'm just pointing it. Okay. Otherwise I have to write it. B's network interface is configured with IP address. This. IP address. IP and it has the MAC address. I have MAC address at the end. It has the MAC address of this. Okay, so here they have given only the MAC address. Okay, right. So anything else they have mentioned? An IP packet P is sent from machine A to machine B. So IP packet is sent from machine A to machine B. Okay. So the question is, what is the suitable IP address for the network interface of A? Network interface of A, that is this one, right? Yeah, so that means a suitable IP address for A. That is the question. Okay, a suitable IP address for A. Right. Now you can see that A is part of this network. Now you have to, right? A is part of this particular network. So that means this IP address and this IP address must resolve to the same subnet ID. Okay. Because you can see it is in this side. Okay. So that is the only prerequisite. There are so many possible IP addresses, but it must, that and this must resolve to the same IP subnet ID. Okay, right. Let me erase this. Right. Now let's look at what is the IP address. This one IP address is 192.168.162 and /27. So this /27 is needed to identify the border. 27 means 888, that is 24, and another 3 bits. So therefore, let's convert this into binary. So that is our starting point, because we have to, the game is here because this is 27. Okay. If it is less than 24, I will convert this one also into binary, but this is more than 24. That is, the game is in the 4th octet. Okay. So let's convert 62 into binary. 662, yes. 31, 0, 15, 1, 7, 1. If I make a mistake, just let me know. 3, 1, 1, 1. So therefore, this is 1, 1, 1, 1, 1, 0. 1, 2, 3, 4, 5, and 0. Yes. And altogether it must be having 8. 1, 2, 3, 4, 5, 6, 7, 8. And other thing is 192, 168, 1. Okay. 192, 168, 1. So then this. And it is /27 IP address. /27 means this border is 24,567, somewhere here. Okay, somewhere here. /27. Again, let me double check. 1, 2, 3, 4, 5, 6, 7, 8 years. 62 is 1, 1, 1, 1, 1. 15, 1, 7, 1, 3, 1, 1. Yes, correct, right? Very good, right? So now, so this is the where the host ID part. So most probably this is our subnet part, but we don't care. We don't need that. What we need is the margin. Okay. So now the question is, what is a suitable IP address for the network interface of A? That means a suitable IP address for host A. Host A. Okay. Right. So how do you find it? Now, since this is where we can play around, we know that it can go from right 0, 0, 0, 0, 0 to that is the smallest number, and of course that is reserved for the subnet ID 1, 1, 1, 1, 1, and that is your broadcast ID, subnet ID, broadcast ID. So therefore, I can assign this any number between these two, not including, right? Not including between these two, but already this number has been used. Right? This number has been used, therefore I can't use this one as well because it has been given to the router interface. Okay, so therefore I can't use this also. So therefore, what is the smallest number? 192.168.1. Here you have the 001. It's very important that you can't touch this part. Okay, right. So therefore, what is the smallest number? 192.168.1. This is 1,248,1632. Right. 192.168.1. 1,248,1632. That is the smallest number. The biggest number is when all these are 1. That is 1,248, 1,248, 1632, 64, 128 minus 1. That is 127. Right? 192.168.1, 127 because 128 minus 1. But 127 we can't use. Here also 32 we can't use actually because that is a subnet ID when all are 0. So therefore you can't take 32. It has to be 33 or above. So therefore it is actually 33 and above. And here 127 we can't use. Why? That is a broadcast ID. Okay. And this one also we can't use. That is already assigned to this one. And this one is, you can see that value 127 minus 1. This is 120. So 127 we can't use. And this is 126. Because not all ones, just this one is 0. Therefore 127 we can't use. 126 also we can't use because 126 is given. Right? No, this is not 126, right? Sorry. Sorry, this is 30. Sorry, I made a mistake. Right? So this is 62. Sorry. So what is this number? 1,248, 1,248, 1632. Right? So this is 32 is the subnet ID. 32 we can't use. Right? 32 we can't use. We can use 33. That is fine. And here 1, 2, 4, 8, 16, 1, 2, 4, 8, 16, 32, 64. Yes. 63. Because 64 we can't use. 1, 2, 4, 8, 16, 32, 64. Yes. 64 minus 1 is 63. Yes, not 127, 63. Okay. 63 is the broadcast ID. So 63 what we can't use. And 62 is already assigned. So therefore 62 also we can't use. Okay. So therefore 62 also we can't use. So that means the highest number is 61. Right. So the lowest number is 33 because 32 is the subnet ID. Right. So the lowest number is 33. Highest number is 61 because 63 is the broadcast ID, 62 is already assigned, and therefore the next ID is 61. So therefore the any number between 192, 168, 133 to 61 can be assigned to this. Okay. Let's double check the answer. Yes, 33 to 61. So why 33? 32 is your subnet ID, right? And also your 60 all are 1, 2, 4, 8, 16, 32, 64. 1, 2, 4, 8, 16, 32, 64, 64 minus 1. 63 is broadcast. You can't use. 62 is already assigned. Therefore, you can't use. Therefore, the highest number is 61. So, answer is 33 to 61. Right? 33 to 61. Okay. Right. So, that is how you get it. Okay. So they have not asked you to justify, but it's always better to justify your answer. Right? So they just so they ask you to justify also. Right? Any address in the range 192, 168, 133 to 192, 168, 161. The addresses assigned to the network interface of A and R1 should be in the same subnet. So that is the idea. Okay. So A and R1 must be in the same subnet. So that is why we come up with this answer. Since R1 is in the 192.168.132/27 network, A's interface should be assigned IP address from the network, excluding the IP assigned to R1. So we have to exclude the IP assigned to R1 as well. So that is why we can't say 62. Right? So we can't say 62. 63 is the broadcast ID. 62 also we can't. We have to exclude, and therefore it is 32 to 61. Actually, you could have explained it even more details. Okay. Right. So any questions? Right. What is the suitable IP address for the interface R2 of R? So R2 is this side. Right? R2 is this side. So have they given any clues about that? So it must be in the same subnet as P. Right? Have they mentioned anything about the BIP? We don't care about the MAC addresses, right? For subnetting. Right. So it says B's network interface is configured with the IP address this. So B's IP address is 192.168.254/24. So /24 means somewhere here 8.16.24. Okay. And this one's IP address must be in the same subnet as this IP address. So that is the idea. Okay. So here again, you forget about the MAC addresses. So now what is 254? 254 is 1 less than 255, right? So 255 is all sevens, all ones. Okay. 1, 2, 3, 4, 5, 6, 7, 8. So that is your 255 because 1, 2, 4, 8, 16, 32, 64, 128, 256. So therefore this is 256 minus 1, 255. Sorry, this is 254. So therefore, there's a 0 here. There's a 0 because it says 254, not 255. Right. So now, and it is /24. So therefore, the possible IP address range is all zeros to all one. Okay. Here all zeros, we can't touch the other part, though therefore the IP address range is, let me erase this. For this subnetwork, the IP address range is 192.168.2254. Sorry, 202. 20, that is all are zeros. Then the biggest one is 192.168, 2 and all are ones, that is 255. But these two are reserved. These two are reserved. So therefore, the smallest IP you can assign here is 1. Right? The smallest IP you can assign here is, because 0 is reserved. The smallest one is 192.168.2.1. Okay. So the biggest is 255, but it is all reserved because that is the broadcast ID. And also they have already used, right? They have already used 254. So 255 we can't use because that is a broadcast ID when all are 1. 254 already given. So therefore the biggest number next available is 253. So therefore the range is 1 to 253 because 254 is already assigned. Okay, 254 is already assigned to a machine. So therefore the answer is 192.168.212, 192.168.253, 1 to 253. Right. 1 to 253. So that is the answer. Okay. So again, the justification is these two IP addresses must be in the same subnet. Okay. So this is a very interesting question. Okay. So actually this is, if you go backwards, you will find that 2019 question is easier than this. 2018 question is easier than this, something like that. But anyway, in a way, these questions are easier because you are not supposed to design a subnetwork. Designing subnetwork we did in the class, right? So they will say, for this department we need 16 computers, that department you need 20 computers, that department we need another 7 computers. That is more challenging. Actually, that those are the type of questions the A-level ICT student get. So if I compare this question with the A-level ICT standard, this question is easier than A-level ICT question. So therefore, don't ever think that these questions are difficult, right? You are in a degree level, right? You are in a degree level. Okay. So if I'm telling lies, I will show you A-level ICT paper. Okay. I need the past papers. Enough. Admin department 5 computers, 1 printer, lab 40 computers, 1 printer, library 10 computers, 1 printer. Right? It was a look at the principal IP block the principal received this address block for the school. The IP address for the computers are to be allocated after making 3 subnets from the address block for the 3 buildings. Assuming each subnet is done, write down the relevant network addresses, subnet mask, and the allocated range of IP addresses for each building using the following table format to present your answer. On Negol under the question. It was a 3 year and it was a retain the question with the network sambando. Wire ganna, network ganna, protocols ganna. යෝගොල්ලෝ හිතන්න එපා මේ නිකන් බබා හුකුම් වෙන්න හදන්න එපා මෙතන ඇවිල්ලා අපි මාර ඇඩ්වාන්ස් එහෙම තමයි මේ සමහර හිතන් ඉන්නේ හරි BIT කරන සමහරව ඉතින් ඉන් BIT කරන්න එනවනේ බබා හුකුම් කට්ටියත් නේද? සූප්පුව කටේ ගහගත්ත කට්ටියත් එනවනේ. ඒගොල්ලෝ ඉතින් ඉන්නේ මේක එහෙම කතන්දරයක් කියලා. නෑ එහෙම කතන්දරයක් නෙමෙයි. හරි IT කරන අයට මේක මහා ලොකු ඇඩ්වාන්ස් කතන්දරයක් නෙමෙයි යා. right. Right. So the question C. Assume that the network address assigned is to be fixed for long time into the foreseeable future. Foreseeable future means the near future. අපිට ඉස්සරහට පේන අනාගතේ නුදුරු අනාගතේ. Assume that the network address assignment is to be fixed for a long time into the foreseeable future. However, the number of machines connected to LAN consisting of switch 1 may change from time to time. You are required to purchase a switch for this LAN and you are under very tight budget. So you don't have money to waste. Okay, you don't have money to waste also. You have very tight budget. Okay, how many ports should be used in the switch? Because the larger the number of ports, the price of the switch will go up. Okay, that is natural. That you propose to purchase. Okay, now read it again. Assume that the network address assignment is to be fixed. That means IP addresses that we are going to assign to these machines, we are not going to change. We need to have the sort of a static IP addresses for computers. That is what is mean with that. Actually, what the examiner says is indirectly they need static IP addresses. You can't just have 10 IP address and give it to 20 people. Okay. No, they need the same IP address in that time period. Okay. So that means definitely if we have 100 computers, we need that 100 IP addresses. That is what they say. Okay. Fixed for a long time, right? Fixed for a long time into the foreseeable future. However, the number of machines connected to LAN consists of switch may change from time to time. Of course, that is okay. So sometimes only 10 computers are connected, sometimes 20, but just because we have different number of computers, it doesn't mean that we can change the IP address. If X computer is not connected, still at any time if X is connected, it must be assigned the IP address that it required. So that means static IP addresses. Okay. So that means if you have 100 computers, we need 100 IP addresses. That is what the examiner is trying to tell you. Right. However, the number of machines connected to LAN consisting of switch 1 may change from time to time. You are required to purchase a switch for the LAN and you are under very tight budget. So that means if we have 100 computers, make sure you buy a switch which support 100 computers, not more than that. Okay. How many ports should be in the switch that you are proposed to purchase? Now, actually, this question has a issue. The question has a mistake actually. The question does not mention whether this switch is to be used for this one or that one. Then switch දෙකක් තියෙනවා. කොයි පැත්තේ switch එකද කියලා කියන්නේ නැහැ. ඒක ඇත්තටම question එකේ දීච්ච අවුලක්. Question එකේ දීච්ච අවුලක්. හරි මම paper එක ඇදුවා නම් අනිවාර්යෙන් මේ question එක attempt කරත් නැතත් හැමෝටම මේ part එකට ලකුණු දෙනවා. නේද මේ part එකට ලකුණු දෙනවා මොකද එයා කියන්නේ නැහැ නේද මොන පැත්තද කියලා switch 1 නේද switch 1 නේද ඒක දැනිය දැක්කේ assuming that the network address assignment to be fixed for long time into a foreseeable future, however the number of machines connected to LAN consisting of switch yes, so the examiner is correct. Okay, switch 1 may change from time to time. You are required to purchase a switch for LAN. So since the examiner says it is switch 1, so that means the examiner must be talking about which part? The left hand side. And in left hand side, we found that this is our hosting side. So how many bits are there? 1, 2, 3, 4, 5. 5 bits means we have 2 to the power 5 possible possible IP addresses, that is 248.16.32, but 2 we have to reserve. So therefore 32 minus 2. So we can have only maximum of 30 hosts because they have already mentioned about this. So therefore, according to the given information, we can see that according to this subnet mask, you can go up to 30 host machines. If we can go up to 30 host machine, because the subnet ID and broadcast ID, you don't need ports for the switch. So that means we need minimum, if we are going to utilize all the IP addresses, assuming that we are going to utilize the entire IP address range, we need 30 because we can go up to 30 host machines. Therefore, we can have switch supporting only 30, because if the switch has more than 30 ports, still we don't have more than 30 IP addresses. Because they say you can't change your IP addresses for different machines. Okay. Whether you change it or not, again, we have only 30 IP addresses. Okay. Therefore, we'll go for 30. Okay. What is the answer given? Is it 30? Yes. Right. Because it's /27, we have this number of bits, but that is that we can go up to 32 IP addresses, but 2 of those IP addresses are reserved. Therefore, there are 30 hosts we can go maximum. So therefore, why do you have to spend more bigger switches than having 30 ports? Okay, so that is the answer. Right. What is the utility which uses ICMP protocol that can be used on machine A to check the connectivity between A and B? Right? Connectivity between A and B means now here we have the machine A, here we have the machine B. We just want to check whether can I access B. I told you if you just want to check whether you can access B, we just ping it. Ping. So the simple tool we use is the ping command or the ping tool. Right? And remember, they have mentioned the protocol for that one also, ICMP protocol. So the protocol behind ping command is ICMP. So A පැත්තෙන් උත්තර උත්තරේ කියන්න පුළුවන් වෙනවා නේ. එහෙම නැත්නම් A to B connectivity එකක් තියෙනවද කියලා බලා ගන්න ලේසි විදිය තමයි මොකද්ද? ping command එක. Right? So in both cases it is ping command. Okay? Right, next question. What is the destination MAC address on the link layer frame? Remember, at the link layer we say that the frames are traveling, that carries packet P when it leaves A. Justify your answer. Now remember, the data packet goes from where? A to B. When it leaves from A, what is the destination MAC address? So this question, this kind of questions, even in A-level ICT, I have found. Right? Exact same question. They ask, මෙතෙන්දි MAC address එක මොකද්ද? අතෙන්දි IP address එක මොකද්ද කියලා අහනවා. හරි? මේ standard questions. හරි? ඒකට past previous tier වැඩි කරන්න ඕන. Right. So this is the theory behind that. So now this is data packet is leaving from A and it is supposed to go through this and reach here. So you have the source. If you are looking at the network layer, right? Of course, then the data packet. So the data packet source IP address will be this one. This one's IP address. Destination IP address will be this one's IP address. And it is going to be the same throughout the transmission. Okay. So everyone will see that source IP and destination IP. Okay. When it goes like this. But because that is a long-term thing. But when it comes to the link layer, link layer. It's from here to here, one particular transmission. From here to here, another transmission. From here to here, another transmission. From here to here, another transmission. So therefore, in MAC or your frame, your data frame doesn't have the IP addresses. It has a MAC addresses. When it is going from here to here, the source MAC address will be this one's MAC address. Destination MAC address will be the switch, the MAC address of the switch. Sorry, not the MAC address of the switch. No. So it will be MAC address of the router. So, right? Because switch is anyway you are connected to switch. You don't need address for this one. Sorry. So it will be from here to here. The same data frame travels. So the source MAC address will be this one. Destination MAC address will be this one. When it is going from this to this, the source MAC address will be the router's MAC address again. That happened to be the destination MAC address previously. And the destination MAC address will be this one. And that is why when you are sending with the destination MAC address, this one, the switch can look at the destination MAC address and switch it here. Of course, there can be some other machines also. Here also some other machines. So it's very important. At the data frame level, it is hop to hop. MAC addresses change, but IP addresses, they don't change. They don't change from the source to the destination. But MAC addresses, here source is here, destination is here, and from here to here, source is here, destination is here. And if you have another switch here, then the source and destination again swap. Okay. But I told you that the same IP address will be there throughout for the data packet. But that change if you have a network address translation that I explained you. If you have a network address translation happening, say somewhere here, then you have your local IP address here and the destination IP address here, which must be a public IP address. But here, still the destination IP address will be the same, this one. But it will remove this local IP address and it will add the public IP address of the router. So that happens only if you are using a private IP address. So because destination is anyway, it has to be public IP address. So in that case only, the source IP address will be replaced by the public IP address of the router. But not in all the other routers, all the other places, it is this public IP, this one, and the source will be this one's public IP address. If no network address translation, it's always this one's IP address, public IP address as the source, this one's public IP address as the destination. Okay. That's something you have to remember. And again, this is something we do for LL ICT students also. Okay. So therefore, don't think right. Paper open kala pen nan open second Thomas mouse second. Right. Right. So now what is the question? What is the destination MAC address on the link layer frame that carries packet P when it leaves A? Right? When it leaves A, the destination MAC address will be the MAC address of the routers, this R1 side. MAC address IP address that will be the R1 interface, the router R's R1 interface MAC address. MAC address number R1 interface MAC address. Minimum address. E0 rolling your MAC address. Destination. E0 rolling. Oh, E0 rolling. MAC of the MAC should be the MAC of the interface R1. Okay. Right. So next question. What is the source MAC address? Source MAC address. on the link layer frame that carries packet P when it reached B? Justify your answer. So again, read the question. What is the source MAC address on the link layer frame that carries packet P when it reached B? So when it reached P means now the data frame has reached here. Your data frame is right here. Now here the destination MAC address is obviously this one. The source MAC address is this one. So therefore, the source MAC address will be the MAC address of the R2 interface. R2 interface එක MAC address එක මොකද්ද? මෙන්න මේ F0 වලින් ඉවර වෙච්ච MAC address. බලන්න F0 වලින් ඉවර වෙච්ච MAC address. Yes, right. That is the MAC address at the R2 interface. Right. So now we are moving to the second topic, the second question. There are, I think, 4 questions, right? Draw a diagram depicting TCP/IP reference model. So that means you just have to draw the TCP, not the OSI model. Remember, there's a TCP/IP is the simplified model, right? So they have not even mention it, right? So they just say refer to this particular diagram in the reference book. So what should be the diagram? So just first draw the OSI anyway. For the exam, you don't have to draw the OSI. So it has 7 layers. 1, 2, 3, 4, 5, 6, 7, right? Physical, logical link or the link, network, transport, session, presentation, application, right? So that is OSI. It has 7 layers. But when it comes to TCP/IP model or the internet model, so these 2 are represented by 1. Network is there. Transport is there. These 3 session, presentation, and application is represented by application. This is physical. And this is called internet layer. The network layer is internet layer. And transport layer is just the transport layer. TCP/IP model. Okay, reference model. So you have to draw this one, TCP/IP reference model. Okay. I guess you have to draw it. What is the main functionality of the transport layer of the TCP/IP model? TCP/IP or whatever the task of the transport layer is having the end-to-end communication, right? And because that is the one that is taking the end-to-end communication, right? So you have to mention it establish end-to-end communication or the socket between source and destination, and it take care of reliability, right? It take care of reliability and also the error handling and other things. Okay, especially the end-to-end communication using the concept of connection. So connection means IP, the IP address and the port number combination from in X to the Y. Okay, and now let's see the answer. It is designed to allow peer entities on the source and destination host to carry on a conversation. Yes, conversation. That is what is meant by session. I think that is very important word that you have to use. Conversation, right? So you can use the word conversation, establish connection. So connection is another word for conversation. Okay, reliability. Those are the words you have to use, right? Shortcut, right? If possible, use all those words and explain a little bit. Okay, conversation. So that is the word that they use in your note, right? ඔයගොල්ලෝගේ note එකේ පාවිච්චි කරන වචන තමයි මොකද්ද? Conversation. බලන්න ඔය විදිහට වචන පාවිච්චි කරලා තියෙනවා. Transport layer. conversation පාවිච්චි කරන්නේ නැද්ද? ඔක තිබුණා මතකයි. ඔගොල්ලන්ගේ නෝට් එක පාවිච්චි කරන්නේ connection. මමත් පාවිච්චි කරේ ඒ වචනේ. හැබැයි conversation කියන එකත් ඔය හැර තිබුණා. I think maybe in your topic 1. So this is the TCP/IP model, right? That I mentioned. You can see transport layer allows peer entities on the source and destination host to carry on a conversation, right? On connection, conversation, right? So, and it use either TCP or UDP, right? ඊට තේරෙන්නේ මේ එක්සැමිනර් ඉතාම අසාධාරණ ක්වෙස්චන් අහලත් නැහැ. බොහෝ දුරට ඔයාලට කියන දේවල් වලින් තමයි අහලා තියෙන්නේ. හරි? Right. So next question. According to TCP/IP reference model, applications do not interact directly with IP protocol. Remember, the applications are not directly referring to the protocols below network, because network, transport layer. The transport layer present or hide the complexity of the below layers, because it is the transport layer that establishes the end-to-end connection and present it as a sort of a reliable concept to the above layers like HTTP, FTP, etc. Right? We discussed that, and it is specifically mentioned in your slides. Okay. However, this is misleading. Then the examiner says this can be misleading as well. Network addresses are not transparent to applications. Right? Network addresses are not transparent to applications. Therefore, if network addresses change, applications may have to change as well. Is that the case? Is that the case? Yes. If you are referring to the IP address, yes. For example, if it is socket programming. Now, if you are referring to the IP address and the TCP or the port, TCP or UDP port, if the other side they change the IP address, you have to change your port. But there's a solution for that. What is the solution? The solution is, rather than you communicate with IP addresses, port combination, especially for as a replacement for the IP address, we have domain name. For example, we have changed our web hosting provider a few times, actually 2 times. So whenever we change our hosting provider, we get a different hosting IP address, because the new hosting provider's IP address is different. But those who are visiting our website, it is not transparent to them. Still, they just type Aurora CSLK. So that is how we hide that IP address to the client. If you want to hide IP address to the client, map it to a domain name. Of course, you have to buy the domain name. So then map it. So that is what all the websites and web applications are doing. Okay. So that just you have to explain that. Just you have to explain that. Yes, if you are working with IP addresses, the other side must know the IP address. But if you want to hide that, rather than IP address, let it map to a domain name and let the clients communicate with the domain name. That is the answer. Okay. Right. There are application layer protocols such as DNS that directly return an IP address to the application. Applications have to know the format and the size of the network addresses to store and interpret them. If the address format or the length is changed, then the application have to change to work correctly with the new format. So that is if you are working at IP address level, right? an answer that demonstrates that there are general protocols or APIs that expose the IP address to application is acceptable. එයා කියනවා එහෙම IP address එක expose කරන තැනුත් explain කරන්නලු. Okay, but the reality is yes, some applications will use IP address, but if you take something like web services or web applications, we don't expose IP address. Rather, we hide the IP address by using the domain name translation. Right? So you have to explain something similar to that. Okay. Right. Third question. Draw a diagram depicting message exchange in the three-way handshake under TCP to establish connection. So that we discuss. Okay. Three-way. Right. So if you have something like this, anyway, they have not mentioned it because they have referred to that, and it is in your slide also. So remember, this guy sent a data packet to this guy with a sequence number, and this guy has to send another data packet with, if this is x with x plus 1 and new y value, right? So then this guy knows that if I send 5, I got 6. That means this guy is now listening to me. Now you have to send another data packet with y plus 1. And y plus 1 මෙයාව එකක් increment කරලා යවන්න ඕන. Now yeah, y, say A and B. Now B knows that XA has received my data packet. That is why I got it y plus 1. Okay, so that is called three-way handshaking. Three-way handshake එකක් වෙනවා කියලා අපි කියන්නේ. ඒක තමයි three-way handshake. It is specifically mentioned in your note. Okay, transport layer. So that is where you use some of the flags also. Yeah, so this is the diagram they are expecting. So you send x, you send y and x plus 1. Now you have to send again x plus 1 and sorry, you have to send even the x plus 1 and y plus 1. Right? X එක දිගටම යනවා x හරි අනිත් පැත්තෙන් දැන් දන්නවා මම කියන දේ එයාට ඇහෙනවා හරි එයා කියන දේ අනිත් පැත්තේ එක්කන දන්න මම කියන දේ එයාට ඇහෙනවා කියලා. හරි දෙන්නට දෙන්න දන්නවා දෙන්නම දැන් ඇස් පේන නැත්නම් කන් ඇහෙන කතා කරන්න පුළුවන් අය කියලා. හරි ඒකට handshake එක තුන් පාරක් කරන්න. හරි so because not only we have to know that I can see his packets, I have to double check whether he can listen to what I am talking. So that is why we are setting. Now when I get x plus 1, I know that this round trip is okay. When this guy get y plus 1, now host 2 know that round trip is also okay. Now both parties are 100% assured that the round trips are happening. So that is what is meant by a three-way handshake. Right. So you have to draw that diagram and maybe explain a little bit. Okay. Right. Next question. Describe SYN flood attack on TCP. Synchronize. Actually, that is, I'm not very sure what is that. Maybe they have mentioned it in your reference book. Okay. So synchronization flood attack on TCP. Synchronization is used to synchronize the two. Actually, I can't remember. Okay. I have not seen much, and I have not seen it in your note also. Anyway, they can add at least one such kind of a question. Otherwise, you will be getting 100. Okay. So what is the answer? A malicious sender can tie up resources on a host by sending a stream of synchronizing segments and never following through to complete the connection. Right. So it's they say you have to refer to this particular thing. Okay. So they are keep sending synchronization without really achieve the synchronization. So that means other scientists keep trying to synchronize with the other party, but it's sort of an attack rather than they try to synchronize, establish a connection. Okay. Anyway, so that is not something directly mentioned in your UCSC note. Okay. Right. Draw a graph of congestion window size versus time to depict how approximate size of the congestion window change with RTT. There is no need to give exact values. So that is what we discussed last Wednesday, I think. The sawtooth diagram. Okay. Sawtooth diagram. Now diagram එක දාලා නැතුව ඇති. Yeah, එයා දාලත් නැහැ. You can see sawtooth pattern. So you have to mention that sawtooth pattern. So I think we discussed that under in your new syllabus also, that is there. I think we discussed it on transport layer, right? Yeah, sawtooth pattern. So the idea is they just keep checking, right, the reliability. Initially, you start with smaller number of packets, then you keep increasing. Remember, there's a pattern 2, 4, 8, something like that. Okay. Yes, you can see 1 packet, 2 packet, right, 4 packets. So initially, you are sending small number of packets because you are not sure about the capacity of the receiver. But once you gradually know about the capacity, you are going at a highest rate. But networks are not perfect, right? Networks are not perfect. So therefore, there can be some issues. Maybe the destination site or maybe network delays. So then again, they adjust it. They adjust it. So that is what is mean by, that is what happens in sawtooth kind of. Now you can see they try to keep increasing and again the packet loss happens. Again, they start and they try to increase it, right? And again, if there's a packet loss, so they again come back to the original location and again they try it. So the idea is try to use your bandwidth and the resources at optimum level, right? Without wasting. At the same time, it's not trying to be too aggressive without knowing the true capacity of the receiver as well. So it's sort of a guessing game. Okay. Right. So that is what they are expecting. They are saying that we don't need exact value, just the shape is needed. Okay, that's it. Right. So okay. Anyway, it's okay because this is the first past paper and this is your immediate past paper. So they are quite a little bit more time. So we will definitely do the 2019 paper also at least, but it's your task to do at least another 4 years of past papers. I told you if you do that, you may not have to go to the exams in 2023 as well, right? So make sure that you don't do that. Okay, right? So it's more than right, it's past 10 also. Right, we stop. So in the Wednesday class, we are going to do the enterprise application development, the last 3 topics, and before, yeah, the last 3 topic, and also I want to do a full revision because we were also guessing at that time. Actually, we were not sure whether we are supposed to use Tomcat or right which server actually. And funny thing is, it's a funny thing. Okay, I will just show you, right? So and remember right, so they reveal this නේද ඒගොල්ලෝ මේක හංගන් ඉඳලා අන්තිමට දැම්මා ගිය සතියේ. අන්න ඒක තමයි කියන්නේ මොකද්ද පාවිච්චි කරන්න ඕන සර්වර් එක කියලා ඔන්න බලන්න වැඩි. හරි. So now in the last topic, right, in the very last topic they are saying මෙන්න මේ servers තමයි පාවිච්චි කරන්න කියලා කියනවා. මෙන්න Eclipse පාවිච්චි කරලා Wildfly පාවිච්චි කරලා මේ version එක පාවිච්චි කරලා වැඩේ කරන්න setup කරගන්න විදිය කියන්නේ මම දන්නේ ඇයි ඒක අන්තිම මොහොතනකන් හිටියේ කියලා නේද. අන්තිම මොහොතේ අන්තිම slide එකේ ඒකත් exam එකට සතියකට කලින් publish කරලා කියනවා මෙන්න මෙහෙම තමයි අපි environment එක setup කරගන්න කියලා. I don't know හරි anyway කමන්නේ අපි guess කරපු එක හරි හරි ඒක හන්ද අවුලක් නැහැ so therefore anyway I'm going to do a full sort of a revision on that also from the beginning and I hope you will be finishing everything right එක subject එකක්වත් තියාගන්න නම් යන්න එපා හැබැයි ඔයාලට ලොකු risk එකක් තියෙනවා නම් හරි අනිත් ඒවායින් ඔයාගේ GPA එක හදාගන්න පුළුවන් කියලා yes so you can skip this and do it in the next time but at least anyway we are going to finish it okay so the Wednesday class we are going to do this and finish it okay because අනිත් topic පොඩි shortcut programming පොඩි web services පොඩි JSON processing එකත් හරියම පොඩි topics තියෙනවා හරි lazy to ඇත්තටම අද lazy topic ටික හරි right so we stop at this point